All right, welcome to another exciting layout techniques video. So what I'm going to do here is I'm going to combine the techniques of setting up over known point and using a mini prism into actually laying out this project. So this is kind of my mock project here, a little scaled down version of what we did in real life. And I'm going to try to take the lessons that we learned from that and hope that we can find a simpler way to lay this out. Part of the problems we were having, so we did this the traditional way. We went ahead, we created points in our file, brought all that into our total station, and we laid it out. The issues that we were having is we were getting different results based on which control points we used, and even when we transferred to control and we said, okay, we're only going to use these 3 control points for everything, we were still getting different results, even depending on the operator. Everybody's eyeball is different when it comes to a level bubble, so part of the idea of using the mini prism is to get that slop out of there from using the prism pole. So we'll see in a little bit how we're going to actually put this to work. But so what I have gone ahead and created is kind of, like I said, a very scaled down version, like a 30 by 40 foot project. So the little boxes represent our 20 by 20 inch weld plates that we were laying out. And the objective was to actually basically lay out our column intersections. So across all of these plates, we wanted our column intersections marked on them. And the reason for that is that there's a transfer plate that goes on top of there. And the way that that is set is based off of those intersecting column lines. And then we would have to go ahead and mark those column lines again, and then the equipment sets on there based on those lines. So we want to get them accurate, and kind of one of the things that we were struggling with is how to make sure that this line and this line are perfect 90-degree angle. We did the whole pull the hypotenuse and all of that. We did everything we should do. And after riding the struggle bus for a couple of days, we got really close. We were within 1/4 of an inch, so that's not bad considering the equipment itself is probably not square, but we're going to start with the best layout we can. So after riding the struggle bus for a couple of days, we forgot that we can use the total station as a theodolite. And basically what a theodolite is, for those who don't know, very old school, there's digital ones now, but anyway, engineering and survey device that turns certain angles. So you can tell it to turn exactly 90 degrees and you measure an exact 90-degree angle. So that's what we're going to do. We're going to use our total station to do that. And the nice thing about a total station is so we can also measure this exact distance. So the first thing I'm going to do is right now I'm set up over this A1 column intersection. I decided, in real life I would go out, I would walk this, I'd probably pull some strings, make sure these are at least somewhat like in a straight line, because we didn't set down these weld plates. So make sure, and then figure out, if like what we had a 1/2 inch discrepancy between the overall dimensions. So decide which way you're going to go with that 1/2 inch. I'd probably go this way in real life, counting on that we're going to start building from this end. So as we go along, what we've had in past experience is that it gets further and further longer. So you end up like about 1 inch off of where you should be, but we'll see. So like I said, pull some strings, whatever. But what I did in this, in theory, is I decided that this right here is where I'm going to start. Whether you lay out that point using the total station or whatever. And then I went down and I decided that this plate, I figured out with this whole column line where this is going to be. I said in real life, I'd probably run a string line across there just to make sure that these aren't too far, like all over the place. So that's what our situation is. I'm going to need to know these angles, which is these angles here. I just converted them to degrees, minutes, and seconds because going to want to know that here in a little bit. And I think we're ready to go on this. I think we got everything we need to know. I didn't sit here and do the math by hand on this, so triangle calculator, just Google triangle calculator, way easier. If you really want to sit here and do some trig, go for it. Mr. Warner would be upset with me, my high school trig teacher, but I didn't want to do it by hand. So I'm gonna go ahead and go do this. So what I did this morning is I laid out my 20 theoretical weld plates. I actually did this laying out the total station just from a blank project, but that's a whole separate class on how I did that so fast. And right now what I have is I have my total station set up over what I'm saying is that A1 column intersection known point. And I just use this tripod stabilizer down there because I'm on a slick floor and I don't want my legs to fall out from underneath it. So a $25,000 piece of equipment, let's not break it. So where I'm going to start right now is down this line. So I'm going to say that this is my whole A column line, and I went ahead and I already kind of threw a mark on here, just like I would do in real life, and say that I'm committing to that's where that's going to be. So right now I just have a blank project set up in TFL. I'm connected to my robot, and I'm not connected to my prism yet, so I'm gonna go ahead and set that out there. And it locked on because I was already kind of pointed in this direction. I'm gonna go ahead, hit this on my lollipop, making sure that it's still set on my mini prism. It is, so we're good. And so I'm going to go ahead, these crosshairs I made, I'm going to line these up on the line that I'm going to say is my column line. And the numbers that I really want to look for are these numbers down here in the corner. So hopefully this focuses. HA that's our horizontal angle. So that's the direction that the machine is turning. So slices of pie, that's what it's turning in. SD is our straight line distance. So the actual horizontal, I shouldn't say horizontal, that's confusing. Straight line distance, the hypotenuse. So basically it's the hypotenuse. It's from the actual lens of the machine to the lens of that prism. That is what that number means. HD is our horizontal distance. So that is from basically that mark on the ground to the mark over here. So that is, it's just our X. And then vertical distance is basically the distance from the lens of the prism to the lens of the robot. So what we are interested in is our SD, our straight line distance. So we know by looking at our print that we want this to be exactly 40 feet from the column intersection that our machine is set up on. So I'm going to go ahead and I'm going to kind of watch this tablet and find a good place to do this. Like I said, this is a little tricky trying to film this and do this by myself. And so I want to watch that, and when that gets to exactly $40 feet, just about there. So that's why I think this is going to be easier, because it's really easier to just make little small adjustments and really dial in this accuracy. So right now, this number, this horizontal distance that I'm interested in is sitting at 40 feet. And that's what I want, because that's where my, what is this, column line 5 is the one that's going this way. So I'm gonna go ahead, I'm gonna mark this. And I'm gonna say that this is my point, my A5 point. Alright. And I'm going to line this up good on this line that it has, because what I'm going to do next is, like I said, how we're going to use this kind of as a theodolite. So I'm going to go ahead and zero out my horizontal angle. Hit that 0 HA button. And what that's going to do for me is it's going to bring that number, that my horizontal angle, to 0 degrees. So, all right. So what that allows me to do is pick this all up, and I'm going to go lay out this entire column line all the way back to the machine, because right now I have it set so that when I know, like, for as long as I keep my marks on 0, that I am in line with the machine. So I'm sure that there are multiple ways to do that. I think this is, it's pretty easy. I'd like to kind of expand on this just because this doesn't require us to have control points, which is always a huge struggle. And I lost my prism, because the bad thing about these mini prisms is that it doesn't necessarily like to stay locked on, just because it's such a small target. So I can't be mad at it for that. There's no way that this is looking at the prism. Yeah, it's locked on the glass behind me. So, that is also the other bad thing about operating in like a passive prism mode, is that it locks onto everything reflective, including glass. So I've had it before where it like locked onto the cab of an excavator, and it was like driving across the project on me. And I was like, what in the hell is going on here? Okay, so now I know we're locked onto the prism. All right, so let's do this again. Now I'm gonna kind of come back to, the edge of where my weld plate would be in theory. Back this up a little bit. And I need to go back this way, I think, a little bit. Nope, go the other way. There we go. And all I'm trying to do is to get that horizontal angle back to 0. We're very close to it. I'm going to say fractional degree or seconds of degrees. It doesn't really matter too much here. I'm sorry that this is super boring, but these are such small little changes here. I mean, we're probably really just splitting hairs here, trying to get it dialed in this close, but I always like to be as accurate as I can. Because, why not? So, and since I have this here, the other thing I can do is I can go ahead and just lay out this column intersection as well, because I know that my horizontal distance from the column line that the machine is set up on to this column line is 30 feet. So So I just gotta back this up to 30 feet. Square the puppy up a little bit, and I'm gonna say that this is pretty good. And we can definitely come back and check that at another time. So I'm gonna do one more, and then I'm gonna move on to the next phase of this, because this is kind of slow and boring, and you guys will fall asleep on me. I don't want that. But I also don't have any cool software to edit anything to speed this up, so maybe when I get a better budget for that, I'll get on that. Yeah. I'll let our marketing department, I'm sure eventually will get a hold of me and tell me that I gotta spice these up a little bit somehow, add some music. I don't know. Struggle's real. This is probably the last time I get to use the shop space to do my thing here. We're losing all of this space, so kind of stinks. I don't know what I'm gonna do then. Go find some other place to loiter in and have people wonder what in the hell I'm doing, because most of the time nobody understands what our group does, so it's kind of fun actually. Kind of like the cats of the company. Everybody's just like, what do you guys do? Line up the crosshairs here, make sure that we're pretty darn close to zero. We're pretty darn close. And I can lay out the column line by, same thing, bring my horizontal distance back to exactly 20 feet. So, what I'm going to do next is I'm going to go ahead and go lay out the other way. So I'm going to go 90 degrees. I'm going to go over there. And the mistake I made the first time was I hit this turning. I'll just say turn 90 degrees. And what I realized is that it doesn't turn to 90 degrees. It turns 90 degrees. So if I'm sitting at where I'm at, like 40 minutes right now, it would turn to 90 degrees in 40 minutes, so which would not be accurate. So if I could do this a couple of ways, I could get this exactly back to zero. So I guess in a way it doesn't work totally like a theodolite in that I can't tell it to turn to a specific angle. I probably can, I just haven't figured out how the hell to do it yet. I'm sure somebody from Trimble will be on here like calling me a bozo because I don't remember how to do it, but I'll figure it out. So I could do it two ways. Like I said, I get it back there where I'm really close to our 0 degrees, and I could tell it to turn 90 degrees, which is what I originally planned on doing. So I still think that that's a good thing. The other thing that I can do, and maybe this is better or worse, I don't know, is go ahead and take all this, see if I can keep this bugger connected. Why not? Alright, helps if I point the prism the right way. And I'm going to carry this over here and see if it follows me all the way around. And now I can go lay out this other column line here. That is, I want to be 90 degrees from where I was. Man, I'm like too old to be sitting on a concrete floor. Waiting for this to find us again, which doesn't seem to want to do. So I'm going to kind of really do the same thing and use this to find our next column line. So we know we need to be at 90 degrees, and we know that our horizontal distance, so our HD number, we know we need to be exactly 30 feet away. So it's the same thing. I'm just going to go and I'm going to make a couple tick marks at 90 degrees. Line this guy back up, make sure that we're at 90 degrees. We're pretty darn close. I mean, this is just splitting hairs there. So now I'm going to go ahead and get my horizontal distance out to exactly 30 feet. So then that would be our column intersection. So I could keep doing the same thing, going down this whole line of theoretical plates. I said I'll probably do one more, just to do one more real quick. I'm definitely not going to do all 20 because that will bore the crap out of everybody. Just watching this horizontal angle, just a tinge over 90. Center of this by coming back to my horizontal distance of 20 feet because that's my dimensions on my plan. And that's that. So I don't know. I don't know if that's better or worse. I think it's better. I know what side I think we're more accurate. There's a couple other things we can do to check. So I do want to go check this hypotenuse out here. So this, I want to go check. Let's see, where are we gonna go? So we laid out this one and this one, and we laid out this one and this one. So I want to go check this one. So we should be, our straight line distance should be out 50 feet, and we should be at a 36.87 degrees. I'm gonna have to come back to that because I probably won't remember that this long. So let's wander over here. So 36. So 50 feet. Told you guys I wouldn't remember that. My degrees, minutes, and seconds this long, so should have wrote it down. Just looking at the wrong number. Horizontal distance. 50 feet, that's what we're after. So, trying to find this. Alright, I gotta go check this quick. Degrees, milliseconds. Alright, so 36, 52, 12 degrees, minutes, seconds. That's what we want to be from the machine. This is probably going to be a little tricky to get, actually. We'll see. Maybe not. And 50 feet, so I'm going to come back a 16th of an inch. So when we do this from the other way, then this gives us a reference point to check. So yeah, I like it. I think that's about it for what I want to do with this. So the next thing I guess I would do at this point is I would go ahead and take a gander through the sight glass on the machine. So go back to our A5 column layout, the very first one I did. And we gently turn the machine in that direction. And this is what would have been handy, like after we laid everything out, this would have been kind of a handy thing to check that we didn't realize that we should have been doing. So all I'm doing is just sighting this in. I said it's kind of hard to hold all of this stuff, but yeah, the lighting actually makes this really tough to see. So basically, are we at 0 degrees? And so I dial it, well, I'm trying to do is just dial it to 0 degrees on here. I'm sorry, I know this is like super fucking boring. So I'm at exactly 0, 0 on my horizontal angle, which is where we want to be. I'm looking down the line. It's really hard to see because of the lighting. That's my fault. Should have used something better to mark this with, but in real life you can look at this, you can see a Sharpie, and make sure that your lines are straight, so you can line that up with the, look down the sight glass, make sure you can see all your lines. So what kind of the cool feature was with this that would help us out And so with this being on exactly 0, 0, 0, go ahead, hit this little button here to turn this machine 90 degrees. And the machine turned exactly 90 degrees. So now it's looking down at our other column line. And we can do the same thing. You can look through the sight glass, see your marks on there, make sure that they all line up and that it's all good to go and you're happy. So sorry this is so super long, but I